Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at a question. This is from section 4.1. It says, determine the location and value of the absolute extreme values of f on the given interval if they exist. So here's our interval, and what we want to do is we want to check if we have extreme values. That means a highest y value and a lowest y value. So that's going to be the absolute min and the absolute max. So when we do that, we want to check certain values. So first of all, we want to check the endpoints if they are included like they are here. So we'll end up checking negative root 21 and positive root 21. But we also want to check the critical values. And that's where this function here, either the derivative is set equal to 0 or it's undefined. So first of all, let's look at this function here in our calculator just to kind of get an idea if this is even a continuous function. So if I pull up my calculator, first thing I want to do is I just kind of want to go in here, put the function in there. So x times 21 minus x squared, or the square root of that. And then I want to go to my window and I want to put my endpoints in as my x min and x max. So I just put the negative, root 21 in here for the x min, and it gave me a decimal approximation, and the same thing for the x max. And then I actually did this problem a little bit earlier, so I played around to make sure I had a good y min and y max value. I started at negative 10 and positive 10, but I saw that I needed to kind of go higher and lower. So when I graph this, I see a function here, and it definitely looks like this function is continuous on that interval there. And it looks like my low point is going to be somewhere around here, and my high point is going to be somewhere around there. And it looks like my endpoints are going back towards y equals 0. And sure enough, if I were to put either one of these endpoints in here, if you square the square root of 21, both positive and negative, you're going to get 21, and 21 minus 21 is 0. Square root of 0 is 0. 0 times any value is 0. So both of these are going to lead me right back to y equals 0. So these are the 2 points that I'm looking to find here, and that's what I'm going to do. All right. So in order to find these, I'm going to need to find the critical points. Now, on this interval here, there's nowhere that this is undefined. The only time this is going to be undefined is when this value here is greater than 21, which will give me a negative number. But since the endpoints are square root of 21 and negative square root of 21, this inside part here is never going to be less than 0, so I'm safe on the undefined part. So really I just need to check the derivative part, which is going to be a little bit of work here. So the first thing I want to do is just get rid of the root and put that in the exponential form here. So that's x times 21 minus x squared to the 1/2. And once I do that, then I have the product rule. So f prime of x is going to be the first value times the derivative of the second value. And I'm going to go ahead and use the chain rule on that. So the derivative of the outside, you just pull the 1/2 out front, 21 minus x squared, subtract 1 from the exponent there, and then times the derivative of the inside, so times negative 2x. So that's the first part of the product rule, and then we add, and then we're going to do the second term, which is 21 minus x squared raised to the 1/2 power, times the derivative of the first term, which is just 1, so that just stays like that. So let's clean this up a little bit here. This 2 here will cancel with that 2 there. So I'm going to be left with, and we can bring this factor down to the bottom. So I'm going to be left with negative x squared, because the x times negative x, all over and bring that down here, 21 minus x squared raised to the positive 1/2. I did that to make the exponent positive. And then plus, and then up here we'll have 21 minus x squared to the 1/2. Now remember, we're setting this equal to 0, because if we set it equal to 0, we're going to find where we have a tangent line that is horizontal. And a horizontal tangent line indicates that we have either a peak or a valley on our graph. So we're going to set this equal to 0. Then we're going to clean this up a little bit, and I'm going to combine this up. So I'm going to multiply this side over here by this. So if I put this over 1 here, and then I multiply the top and the bottom by 21 minus x squared raised to the 1/2, I'm going to get this. I'm going to get negative x squared all over 21 minus x squared raised to the 1/2. And then this, since I multiplied the bottom by that, it combines with this for my common denominator. If I multiply the top by that, then we have the same base. We just add the exponents. So 1/2 plus 1/2 is 1. So this just becomes plus 21 minus x squared. So nicely for us. So this becomes negative 2x squared plus 21 over 21 minus x squared raised to the positive 1/2. Now, in order for this to be 0, basically our top has to be 0 and our bottom has to be a non-zero. That's how we get a fraction that has a value of 0. So we're going to set the top equal to 0, and really the only values on the bottom that's going to make this equal to 0 are those endpoints there. So I just need to make sure I don't get those endpoints back, and we should be good. Give myself a little bit more room here. All right, so we're just going to set the top equal to 0, so negative 2x squared plus 21 is equal to 0. Negative 2x squared is equal to negative 21. X squared is equal to 21 over 2. And finally, x is equal to the square root, positive and negative, 21 over 2. 21 over 2. So those are my two critical values, and I can tell you right now, since I looked at my graph, let's pull that graph up here again, I can tell you with a pretty good amount of certainty that this value, this y value at the top here is going to be positive square root of 21 over 2, and this bottom value down here is going to be where x is equal to negative square root of 21 over 2. And let's kind of verify that. So if I were to go to second trace, and we're going to find the maximum here, and I need a left bound. I'll do the left bound right here, and I need a right bound, and I'll just do it somewhere on the right of this point up here, and I say no, I don't want to guess, and we can see that we get about 3.2403684. So what I want to do is just kind of write that number down here. And now, if I go out of here, I'm going to do the square root of 21 over 2. And if we're right, that's going to be about the same approximate value there. And there we go. There we go. It's almost the same exact value. This one is just slightly different, and you're going to have some of that in calculator. But 203, at least to 4 decimal places, those values are the same. So that tells me that this is the correct answer. We can do the same thing with the bottom. So what does that mean? That means that we're going to have a maximum value, and let me go back to my graph here, at x equals the positive square root of 21 over 2, and y equals 10.5. We're going to have an absolute minimum value on this interval where x is equal to negative square root of 21 over 2, and y is going to equal to a negative 10.5. Let's just verify that. So if I go here, I hit vars, function, I want to evaluate this at negative square root of 21 divided by 2. I should get negative 10.5. And I do. So it looks like this is a, what kind of function? That would be an odd function, right? Where it appears to be reflective over the origin. All right, and I'm sure we could check that if we wanted to go back to pre-calculus, but that's all I got for you today. If you have any questions, please let me know, and I hope you all have a great rest of your weekend. Thanks.